Here we have a pre-calculus problem. Okay, let's go to the question. Find the specified nth term in the expansion of the binomial, that is 9a positive 5b to the fifth power n equals to 5. Since n equals to 5, we have to find the fifth term in the expansion of this binomial. Okay, let me consider a binomial that is x positive y to the nth power. Okay, in the expansion of this binomial, if I want to find a particular term, say r positive 1th term, there is a formula. So for that, what we have to do is we have to consider this and the exponent we have for the binomial NCR. We have to write a combination NCR, and now we have to take the x over here. It has to be raised to the power of n negative r. And now we have to take this y, and this y has to be raised to the power of this r. So this is a formula to get r positive 1th term in the expansion of this binomial. Now let's compare the binomial we have over here in our problem with x positive y to the nth power. At the place of x we have 9a, at the place of y we have 5b, and for n we have 5. Okay, now if I want to get the fifth term in this in the expansion of this binomial, I have to find the value of t5. Okay, if I want to get t5, what value should I plug in for r? I have to plug in 4 for r, so that I will be getting 4 positive 1 will be 5. So we can write the fifth term in this form, that is t4 positive 1, so that we will be able to identify the value of r. Okay, now on the right side, what value should we plug in for n? So because n is the exponent of the given binomial, in our binomial the exponent is 5, so we have to write 5c, and for r we got that 4, so 5c 4, and now we have to take x. At the place of x we have 9a, so 9a has to be raised to the power of n negative r. For n we have 5 in our problem, for r we have 4, and now we have to take y. At the place of y we have 5b, so 5b has to be raised to the power of r. So instead of r we have 4, so it has to be taken. Okay, now what t4 positive 1 is 5, that is we got the fifth term on the left side. Now we have to simplify this one. Okay, so now to evaluate the combination 5c4, let me consider an important property in combination, that is NCR equals to NC n negative r. Usually we use this property if the value of r can be reduced. Okay, now let me take the combination 5c4 and let me use this property over here. In that case I'm getting 5c 5 negative 4, then I'm getting 5c just 1. Okay, when I use this property in our combination 5c4, the value of r 4 has been reduced to 1, so the value of this one and this one are equal. In any combination, the value of r is just 1, so then the value of the combination equals to the value we have at the place of n. So here we have 5 at the place of n, so its results just 5. So we write directly result without any calculation. So because of the value of r, that is 1, since the value of r is 1, so the value of the combination equals to n. So for n we have 5, so the value of 5c4 is just 5. Okay, now let me plug in 5 for this one, 5c4, and times 9a to the power of 5 negative 4 is just 1. Okay, now what we can do is we can write 5b 4 times and multiply them, because we have the exponent of 4. So 5b times 5b times 5b times 5b. Okay, now we have t5 equals to 5 times 9a to the first part is 9a, and here we can multiply this 5 times 5 25, and 25 times 5 is 125, 125 times 5 is 625, and b times b is b square times b is b to the third power, b to the third power times b is b to the fourth power. Okay, now we have to multiply the numbers over here, 5, 9 and 625. When I multiply these three numbers, 5, 9 and 625, I am getting 28,125. Then we can write the alphabet, that is a b to the fourth power. Okay, now I got the fifth term in the expansion of the given binomial. The fifth term is 28,125 times a times b to the fourth power.